Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, today we are going to start with the third session of gas laws, that is Gay-Lussac law and gas equations. But let's first have a quick view on the last session. We studied the Boyle's law and Charles' law. That is, when the volume of gas decreases, pressure of the gas increases. That is, they are the inversely proportional to each other. And when the volume of the gas increases, pressure goes decreases, temperature remaining constant. In Charles' law, we studied when the temperature of a gas increases, the volume of gas also increases, and the pressure goes decreasing, volume of gas decreases. That is a directly proportional expression, keeping pressure constant. We also studied this Boyle's law with the numerical presentation is this. V is inversely proportional to 1 by P, that is volume is inversely proportional to pressure, keeping temperature constant. We also studied Charles' law with the presentation of V1 upon T1 equal to V2 upon T2, that is V is directly proportional to temperature, keeping pressure constant. And this session will be studying Gay-Lussac law, which is also called pressure law, and gas equations. Now friends, let's come to the Gay-Lussac law. We write like this. Keeping it to center. What relation it gives? That is, it is a relation between pressure and temperature. What is the relation? That is, pressure is directly proportional to temperature, keeping volume constant. That is, volume of the gas is constant. What is the mathematical presentation? That is, if there's initial pressure, initial temperature, final pressure and final temperature. This is the numerical equation which we'll be using into the numericals, keeping volume constant. Now this is a relation. Now what it says? It says when the temperature increases, pressure increases. What happened actually? Let's take a daily example. We all have pressure cooker in our kitchens. Let's take two pressure cookers. These are the two pressure cookers. Keeping on the flames. This is a flame on the gas. Keep this flame on low and this is on high. There's some water and some gas molecules in it. Now what happened at this temperature? Some molecules of the gas is having collision between them and also with the wall of the container, that is the pressure cooker. And when we increase the temperature, what happens? Increasing temperature will increase the kinetic energy of the particles, of the gas particles you can say, which will collide with each other and the walls of the container. Here it's a pressure cooker. And what happens? The pressure goes on increasing here, and it will gives a whistle to decrease the pressure in the cooker, right? So what the theory says, when the temperature increases, pressure increases. Vice versa, when the temperature decreases, pressure decreases. As the average kinetic energy of the particles of the gas increase or decrease according to the temperature, keeping volume constant. Now, I hope you have understand the proper theory of this gas law. Now, if we plot a graph, pressure against temperature, what will happen? It's go like this, keeping V constant, right? So it's a very simple to understand that when the temperature goes on increasing, the pressure goes on increasing simultaneously. As we have taken that daily example in the pressure cooker, you can also do it yourself at your home. You can take two pressure cookers, fill with some water, some lentils, cereal, and you can keep these two cookers in the two gas, and you can observe what happens at the low temperature and at high temperature. Now let's come up to the theory part. Yes, we have the relation, that is the temperature and pressure, keeping volume constant. What is the relation between them? This is directly proportional to each other. That is, temperature increasing, pressure goes increasing. And when temperature goes decreasing, pressure goes decreasing. But the thing, who is this great scientist who has given this law? He is Sir Joseph Louis Gay-Lussac. He gave this law in early 1800s. Now, can you try to understand this cartoon picture, keeping this particular as a standard? Yeah, hey, if we decrease the temperature, what happens? The pressure we have to make goes decreasing. Here, if we increase the temperature, there are two men to make stable this particular container so that the gas doesn't go out. There's a funny cartoon picture, but the law is typically made you understand this particular picture. Now let's continue with the definition. That is, the law state that the pressure of a sample of a gas at constant volume is directly proportional to temperature in Kelvin. Yes, keep in mind that is in Kelvin. Now what's the mathematical expression? That is, a P is directly proportional to T. What is T? That is absolute temperature. It is in Kelvin. Now let's take this container example. While first having that is same number of gas molecules into the containers. First is with the minimum temperature and second is increased temperature. What will happen? The collision goes increases as the kinetic energy of the molecules goes increasing, and hence the pressure goes on increasing. Let's see it graphically also. Once again, that pressure of the fixed amount of gas at a constant volume is directly proportional to its absolute temperature. This is the graph we have just studied. It will be the straight line. Now let's come up to the numerical part. That is the main part of any of these mathematical expressions. It basically comes in the exams. So first let's read out the numerical. That is, it says 10 liters of a gas is found to exert 97.0 kilopascal at 25 degrees centigrade, or say Celsius. What would be the required temperature to change the pressure to the standard pressure? By all the numericals, we have to remember the units, and second, the conversions of units. That is very important. Now let's solve this numerical. What was the question? Question says 10 liters of a gas is found to exert pressure of, that is pressure 97 point kilopascal at 25 degrees centigrade. Now the question is, what would be the required temperature, yes, in Celsius, to change pressure to standard pressure? Now first of all, you have to go stepwise. First step, read the question carefully. Second, write the given. That is, here volume is given 10 liters, which is not changing, that is a constant part. What is given? Pressure. The initial pressure has been given. Also write the units simultaneously. It is given first temperature, that is 25 degree centigrade. As I have told you, every numerical in these gas laws, you have to convert the temperature into Kelvin. It has to be in Kelvin. So first, let's convert. What is the conversion? We know that Kelvin is equal to this much, right? So we add 273 plus 25, which come up to be 298 Kelvin, right? Now third, what do we have to find? We have to find the P2, that is final. We have to find temperature, the final temperature to change the pressure to the standard pressure. That is, P2 is hidden, but it says that is standard pressure. What is standard pressure? Standard pressure is 1 atm, that is 1 atmosphere, is equal to 101.325 kilopascal. So we have to write P2 is 101.325 kilopascal. See, all the units of initial and final variable should be same, right? And fourth, what will be the formula which we are going to use? That is P1 upon T1 equal to P2 upon T2. That would be very easy to understand the numerical when we go step by step. Now we just have to calculate. We know this, we know this, we know this. We have to just calculate. That's the simple calculation we have to do. Now let's calculate the values. Put the values. That is, it comes out to be 4.101.325 into 298 upon 97. This is Kelvin. After calculation, you'll be getting this much of amount. Now what happened? Our question says that it has to be in Celsius, right? So we have to again convert Kelvin to centigrade. That is what we have to do. We have to minus this much of amount to 273, which will come out to be 38.28 degrees centigrade. So this is the final answer. I hope you have understood this numerical, the simple numerical. Now let's come out to the second part, which is the gas equations. What is gas equations? We learned Boyle's law, we learned Charles' law, we learned pressure law, that is Gay-Lussac law. If we combine these three laws, we get gas equations. That is Boyle's law, Charles' law, and Gay-Lussac law gives combined gas law, that is a P1 V1 upon T1 equal to P2 V2 upon T2. Just remember that in all these gas laws, when we calculate the problem sum, we have to give temperature into the Kelvin. All right. So let's go into details. That is, the volume of a given mass of a given gas varies inversely as pressure and directly as absolute temperature. There are many times when we increase or decrease pressure, temperature, there is a slight increase and decreasing of volume because three are interrelated to each other. So it's very difficult to keep one variable constant. So it comes out to be gas equation. If you see the mathematical expression, it will be P1 V1 upon T1 equal to P2 V2 upon T2, where P is pressure of a gas, T is temperature of a gas, V is a volume of a gas. Now let's see how these laws combine to give a gas equation. First, it's Boyle's law, where temperature and mass of the gas is constant and pressure and volume are inversely proportional to each other. In second, Charles' law, where pressure and mass of the gas is constant and where the volume and the temperature are directly proportional to each other. Gay-Lussac, we just understood that volume and the mass of the gas is constant, where pressure and temperature are directly proportional. So we get combined law, that is P1 V1 upon T1 equal to P2 V2 upon T2. These are the some equations, derived equations, which will be used in equations like numerical, in which you will be given different kind of situations and different kinds of questions to find out the initial pressure, initial temperature, final volume, or initial volume. You can use this derived equation of gas laws to find these respective variables. But before starting with the numericals, we should understand these very important points. Thus, as volume of a gas changes with the gas in pressure and temperature, it is necessary to take standard values of temperature and pressure to which a volume can be referred, right? First, what is standard temperature or say normal temperature? We call it STP or SANTP. that is 0 degree Celsius, that is 273 Kelvin. What is standard pressure? It is 760 mm of mercury, or say 76 centimeter of mercury, or 1 atmosphere. In all these gas equations, as I have told you, temperature has to be in Kelvin, but units of the pressure volume can be anything as long as they are into same side, both with the same sides. All right. You refer again. Just read out again the third point, the fourth point, and the fifth point. I hope you can solve this grid now. There are 7 different questions having different finding variables. I have given the question marks. You can use these equations which I have told you earlier, the derived equations, and you can solve this grid. You can also tell me this activity, why this Gay-Lussac law is having this air balloon. In other words, I can ask you how this air balloon refers to Gay-Lussac law. I hope you can understand these laws properly and make this activity successful. You can discuss with your partners, you can discuss with your teachers. I hope you'll be getting answers. So this was the last session of gas laws. Now the next session will be understanding absolute zero and ideal gas equations. So thanks for today.